and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Jody Saultz.
Thanks, William. Thanks for joining today. Tech to Tech, presented by KYZEN. This is the fourth and final part of the Stencil Cleaning Series, and the subject is going to be on paper selection. So just real quick, wipe sequence and paper. Most printers allow the operators to program a variety of wipe sequences using a wet sequence, a dry sequence, or a vacuum. On the paper side, not all papers are the same. You have natural fiber papers, you have synthetic papers, and the type of paper that you choose will have a drastic impact on the speed and the wipe sequence. And also, if you're indexing versus continuous paper roll, this could get you into using a lot more fluid based on consumption. So let's talk about these papers. Most of the industry experts out there estimate that 50 to 60% of all SMT defects stem from stencil printing process. I would probably say that number, if you're talking about it, is probably low. I think it's more close to 90%. There's a lot of things that can cause or go wrong upstream if the stencil printing process is not optimized and it's not running smoothly, which causes upstream operators to look into their process. So if they're having an issue in reflow or anything upstream, more than likely it's because of the printer. So fixing the stencil printing process, it pretty much could fix the whole entire SMT line post printing. So in general, there's two types of papers. There's papers with synthetic fibers, like I said, and these are basically held together with glues. These are called binders. And then there's a paper made from a mix of natural and synthetic fibers, and these do not use glue. Printers are only as good as the material that you put in them. The same can be applied to the printer. So using low-cost paper directly influences the wiper ability to clean the stencil. Wiper paper made with synthetic fibers held together with glues. These are called binders, like I said. And then the wiper paper made of a mix of natural and synthetic fibers that do not use glue. I say it to easily understand. Cheaper paper is the ones that use with glue, and the more expensive papers do not use glue. So papers that are made with glue binders, these are synthetic fibers found in paper, and these are usually polyester or rayon. Um, these papers have harder surface. They're 30% of the paper weight is from the glue itself. They have low tensile strength and they absorb less contamination. So they don't actually pull that paste down inside them as well as a paper that's not made with glue binders, because the glue is basically filling up all the cavities in the paper, and they're less expensive. So I don't recommend using the cheaper paper versus a more expensive paper. So hydro-entangling. What is hydro-entanglement? This is also known as spun lacing. Hydro-entanglement process entangles fibers to give them strength with no chemical binders. This goes through a fine high-pressure jet of water that basically sprays the fibers on a high-speed conveyor, and this basically is intermingling the fibers, resulting into a bonded non-woven fabric. Non-wovens made by this method have high fabric integrity, so they're very strong, and the material has very low lint and particular particle generation. So there's nothing there to basically recontaminate, or that could be recontaminated into the paste itself. So the hydro-entangled paper, in my opinion, is the better paper, or basically the more expensive paper. Hydro-entanglement, single fiber polymers. This material, hydro-entangled single fiber polymer, is based on regenerated cellulose. This fabric is synthetic, so no natural fibers or binders. These fibers are smooth, they're consistent, they're hard, and basically these papers, they include voids and cavities to help pick up that solder paste. Like I said, we need a cheaper paper. You don't have those cavities that helps the vacuum basically suck that paste down inside the paper. There's no cellulose to rip or shred, and the binders dissolve and could contaminate the stencil. So like I said, anytime you're using these cheaper papers that have glue associated with them, you could recontaminate the paste and have an effect on the stencil. So why so much talk about the paper? Because paper meets chemistry. Each paper type has different absorption rates and properties. Each chemistry is different in density. The surface tension is different. So how a engineered chemistry versus per se alcohol will basically saturate different, whether you're using a cheaper paper or a more expensive paper. But even when you think you have your process dialed in and you're using cheaper paper, you're going to absorb a lot more um, fluid to wet the paper than you would if you're using a chemistry or a paper that basically doesn't have glue in it. Basically, the glue is per se just getting in the way. So choose your paper wisely. So the interaction between paper and chemistry. This is just a quick video. You can see the delivery system is wetting the paper. Um, I go into a lot of factories and I see this across the whole paper. If you look at the surface that has the 3 ribs in it, that is the only part that needs to be wetted on this paper. If you're wetting to 1 to 2 inches to each side of that, you're basically wasting a lot of fluid and you're wasting a lot of paper. So do your homework and optimize that spray delivery system. Use a more expensive paper that saturates your fluid a little bit differently and saves you on paper. So this is a underside wipe video. Just basically, a lot of times, well, actually, when you're using a stencil, you can't see any of this process take place. So I just thought this would be a good video to show on this clear stencil, basically what happens when the stencil is being cleaned. So this wiping that takes place on the underside, basically everything's the board is removed. It's on to the next process. It goes through this cleaning cycle. The board or the paper is saturated with fluid. You can program these to go in forward and then back. But like I said, this is just an example to kind of show um, the underside wipe process, what happens with that paper. Using the right paper can cut your paper and chemistry consumption in half. If you use cheap paper, like I said, and um, let's say alcohol even, you're going to use a ton more paper and you're going to use a lot more fluid versus an engineered chemistry on a more expensive paper, and you're going to use a lot less paper with the engineered chemistry. So it's going to save you tons and tons of money. Paper is expensive and you go through it quick. So in conclusion, understand those key elements in the solder paste printing process. Um, whether it's a wet, dry vac, wet, vac, dry. I always say end in a vacuum. What you do up front really doesn't have a huge impact. And in some cases, I don't even use the dry. I let the vacuum take care of that. Maintain control of the process. It's where most of the rework comes from, and it's where most of the money is in the SMT. So when your cross process gets out of control, it can cost you thousands of dollars. When the problem arises, take a 5-minute overall systems check. You guys are familiar with the printing process. You follow it, you know it, you see it every day. So look into those issues. If you have questions, if you wasn't here when we did part 1 through 3, it talks about all these, and there's some troubleshooting that you can do. So I urge you to go back and look at those. And then 80% chance that you're going to resolve that problem in the first 5 minutes if you just look for it. It's a specific defect continues, follow some logical troubleshooting guides, whether it's delivery system, paper, your paste is too cold, it's contaminated, you're using the wrong chemistry, that's being recontaminated or remixed with your paste. So look into those and improve your process and optimize from one element all the way to the end. And with that, I'll go through some questions that's been asked on this topic. So how can you save money by using more expensive paper? Like I said, if you use a more expensive paper and you use the right engineered chemistry, you're going to use a lot less paper. Just think about it. If you go from printing 3 boards and you're now able to go to printing, let's just use a round number, let's just say 10, because you're using a good engineered chemistry and the right paper, that is a huge, huge cost savings on paper when you're not having to wipe every 3 boards, and you can make that, 9 or 10 before you have to wipe. So you can save a ton of money. Can you reuse paper when you get to the end of the roll? Absolutely not. I see it happen. Sometimes customers will basically flip the roll over and they'll use the bottom side. All that's going to do is cause recontamination, whether it's in the holding tank for the fluid on certain printers, for the delivery system of the engineered chemistry, or you have the possibility to recontaminate or to lump hard solder between the stencil and the board itself. So I urge you, please, please don't reuse your paper. When you're done with it, one side, be done with it. So how does glue bound paper affect stencil cleaning? Like I said, this is basically a cheaper paper. It doesn't have the pockets in it. Glue mainly fills those pockets, so it doesn't do a very good job of cleaning the stencil. So in some cases, a customer might say, oh, well, the chemistry or whatever that engineered chemistry is not working well, which in most cases, it probably has to do with paper speed, and using a paper that has been bounded with glue. So it absolutely will have effect on your stencil cleaning. And does chemistry saturate paper differently than IPA? Absolutely. Whether you're using the more expensive paper or the cheaper paper, depending on what fluid you decide to use because of the density and the surface tension of that makeup of fluid, um, they are going to saturate paper differently. So I hope that you go to the more expensive paper and optimize your process, but if you don't, you're still going to have to optimize your delivery system to the paper, because it's going to happen. The saturation of paper is going to happen whether you're using a more expensive paper or a cheaper paper. I just say do your homework, save yourself some money, and have a process that is working well for you, that doesn't stop your line. And with that, I'll turn it back over to William. Thank you.
Thanks, Jody. Thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.